this guy right here, he's going that way at 35 kilometers per hour. Ship A. What about ship B? Ship B is sailing north at 25 kilometers per hour. Okay, you're going that way. 25 kilometers. It's all about pictures, right? So far, so good. Hey, what time was this again? When did this happen?
12 o'clock.
You're the best. It was the very first statement. Sometimes we'll forget about it. The problem is you can get all confusing. You're awesome. You said this was at noon. So this was noon time, right here. This is the picture. And then they move. And then here's the question. How fast is the distance between the ships changing at 4 p.m.? So we need to change our picture.
So after
And
4
then we'll
hours.
never look at this again. Right? What's going on at 4 p.m.? So let's just do it per hour, right? After 1 hour, how did B move?
25 miles.
25.
25, yeah.
Right, 125 kilometers. At 1 p.m., where did this guy move?
35.
35. Right? But that's at 1 p.m. We gotta get to what?
4.
All right, so I think we could jump to it. Let's start with B. Where will B be at 4 p.m.?
100 kilometers from.
Oh, look, 25 kilometers, 25 kilometers, 25 kilometers, 25 kilometers. It'll be 100 kilometers north of this location, right? So I'm gonna do that. I'm just gonna extend the thing out. All right, way up here. There, that's good enough. All right, this is 4 p.m. There we are, and this distance right here is what?
100 kilometers
100 kilometers is that length.
from. Yep.
Now let's move letter A. And I don't know, you're gonna have to help me out with this. Is A gonna stay on this side, or is A gonna get to that side?
No, 140. 35 times 2 is 70 times 2, 40.
35, 35, 35, 35?
140.
140? Because sometimes in these ship problems, anybody in here ever use WebAssign? They'll take this problem, she knows this, and they'll make like 8 random problems like this. And, you know, I get a lot of emails from students. Well, sometimes it depends on the number they choose here. If they, let's say they always use 150. Sometimes ship A will get what? Over to here, true? But sometimes it stays on this side of this what? Vertical line. Either way, aren't we still gonna have a right triangle somewhere? Good. So I just wanna point that out. But if it went 140, 35, 35, 35, 35, then I don't care about this anymore. You're saying right now it's what? 10 kilometers for that distance right there, right? There we go. That's my image. And the question was, let me read it to you. How fast is the distance between the ships? Here it is. Here's A, here's B. Here's the image we want. That original image we had before gone. So far, so good? Now I want you to tell me something. See this length here? Is this length increasing or decreasing in that
Decreasing.
right triangle? Because we're about to apply Pythagorean theorem and then differentiate it. So we got to think about the sides of the right triangle. That length is decreasing. Excellent. So we're going to make the rate what? Negative?
Negative, yep.
When we do the math formula. Does that make sense?
Mm-hmm.
Good. Go ahead.
Explain why it's decreasing.
Oh, you saw how, like, maybe I should draw a couple images. First it was like this, and here's A and here's B. Right? Remember after 1 hour, this went 35 this way, this went 25. Then, an hour later, this what? What happened to this distance? Did it shrink a little bit? Right, that distance, right, and then B what? This length's increasing, but this length is what? Decreasing. Do you see that? So at that moment, at that exact moment, 4 p.m., we can see the length of that right triangle there, that length is actually decreasing. But what's interesting, I hope you follow this, what's going on an hour later? Even though we didn't have to do this at 5 p.m., everyone, but what the heck's going on at 5 p.m.? This thing is now 100 and what?
40.
25 for that one? Does everyone agree?
Which one is 125?
When is going by 25s?
Okay,
This one's going 25,
Oh, at
25.
5 p.m. Okay.
Yep,
Okay,
at
got
5 p.m., even though we don't have to do it. So that'd be 125, it's still increasing. But then this ship would have been where? Over here, how far if it went 35 kilometers?
25.
25, oh, I gotcha. And that would have been 25 over here. But we got a totally different right triangle now. Look at this right triangle. And what's going on with that distance?
Increasing.
Isn't that increasing? So do you follow me? It depends on the time and the moment, but we can see in this one, okay, at that moment, that length of that right triangle was shrinking. It was decreasing at that exact moment. But yeah, an hour later, you got a picture like this, and this distance is actually increasing. Cool. So, but because it's decreasing, when I do my math formula, everyone, see that 35? In my math formula, I am gonna put that rate. Do you follow me? Does everyone see that? That's the only thing tough about related rates, is when we look at an image, whether it's a sphere or a circle, triangle, in this case, right triangle, and we're looking at that shape, we're talking about each length. Is the length decreasing or increasing? So when we do the math formula, we can say it's a positive or negative rate, because it is rate of change.
If you put the point of origin, then in that way it becomes much more, because that's the negative x, you're coming from negative x,
That's good.
right?
I like that. Make that the the actual origin.
Yeah.
0, 0, right there. And you go, yeah, that's decreasing. That's negative. Or like he said, it's on that side. All right, everyone. So I am going to make sure that I'm going to call this side right here, not its length negative. That's not negative 10. That's still positive 10. But the rate of change of this side will be negative 35. So want to go there? Cool. And you also note if it was 5 p.m., this rate would have been positive here. This rate is still positive. Cool. All right, so we're going to set this thing up in a second. Let me see if we got everything. Do you want to use A, B, and C? Will that work?
Yeah, that's cool.
But these are capital A's and B's, so I'll use lowercase a and B, and C to represent the lengths of the sides. So, right here, everyone, what is the length of that side right there?
10.
A is 10, right? 10 kilometers. Not 10 kilometers per hour, A is 10 kilometers. What's B equal to?
100.
100 kilometers. I am now stuck. They didn't give me the length of C. What theorem?
Pythagoras.
Pythagoras. And we talked about common right triangle lengths. I don't think this is one of them. You know, I don't think this is a 3, 4, 5 or a 5, 12, 13. You know, you have to really do Pythagoras there. Okay. What's 10 squared plus 100 squared?
100.5.
Take the square root of this. That's a 1, 0, 0, 0, 0, and then I add 100. Square root of 10,100? Is that what it is?
Mm-hmm.
I'm gonna write it like that, because I imagine it's irrational, huh?
100.
All right, so I'm gonna write it. This is the square root of 1, 0, 1, 0, 0. I'll just leave it like that.
It's 100.5. That's
Was it exact?
no 100.4 irrational.
It's irrational. And everyone, it's irrational, so I'm gonna leave it like that.
Okay.
I love it. Hey, it is 100.5. I'm glad you did that, just to give us an idea what this number is. I'm gonna leave it irrational just so that we'll stay consistent. Any math problem we solve, we won't round to the final what? Final answer, right? I worry someone puts 100.5 on and they divide something and it gets that accumulated round off here. All right. B is 100. Little a is 10. What is dB dt again? How fast was that side increasing? They gave us that rate. 25 kilometers per hour, right?
Uh-huh.
And everyone, do you agree it's positive?
Yeah.
That length's increasing. What's dA dt? This.
Negative 35.
Does anyone see that? And do you know why I'm making it negative, Amber? That's gonna be
Yeah.
dA dt.
Yeah.
Oh yeah, it's shrinking. At that moment, at 4 o'clock. Most of my WebAssign emails that I receive will be on that concept. The student did everything right, but was using positive 35 in their math. Wasn't getting the answer in the WebAssign. You know, I've done this I've done this 10 times, and I keep getting it wrong. I'm usually like, I bet you that's it. That's usually the problem. It's not their sketch. They make a great sketch. All right, I'm going to start out with Pythagorean theorem. A squared plus B squared equals C squared. Differentiate both sides with respect to t, right?
Mm-hmm.
2a, d dt. 2b, db dt. 2c, dc dt. We differentiate everything with respect to time. Cool? Now, want to take those 2's out? What I mean is divided 2 on both sides? Okay. Got an A times a D80T. Get a B times a DBDT. C times a DCDT. All right. You're 10. You're negative 35 kilometers per hour. You're 100. You're 25 kilometers per hour. You're the square root of 10,100, and you're X. So what is negative 350 plus 2,500?
$21.50.
And then what's 2150 divided by? And now we'll approximate the answer.
21.29.
29? I'll go to 1 decimal place. What would that be? 21 point.
40.
All right, I'm gonna squiggle, everyone. 21.4, what's my units?
Kilometers per hour.
Kilometers per hour. Yeah. You probably need 20 of these after this. Don't have to be ships, it could be trains, it could be planes. There's a problem with the plane if you want to do it. And if you notice, that when there's a lot of right triangle problems in here. Not all of them. We did a cone, we did a sphere, we did a circle, but a lot of them are. Hey, can we do one off the practice set? Anybody need a copy of this? They're just additional problems when you've expired, you've done every problem out of the text that we talked about. And you just want extra ones? But I saw there was a related rate problem on number 22. But I like it because it's multiple choice, you know, you're like, ooh, I gotta figure out which answer it is. Anybody need a copy?
Yeah, so after you got the 2150, then what did you have?
Oh, so this was, I'm sorry, so this was 2150 equaled this number times DCDT,
Oh, because
and then
that
I
was
just divided it.
Okay, because C is the 101 or 100.5.
Yeah. And Amber, the only reason I didn't make it a decimal, I was like, okay, it's irrational, so I
But
would've
you
had to
just
write.
left it as a square root? Okay.
Yeah.
Okay.
Hey, if you wanted to, Amber, you could have left your answer like this. 2150 divided by the square root of 2. Just sounds better when we talk about the actual ship. Anybody need one? All right, what do we got here? A railroad track and a road crosses at right angles. An observer stands still on the road 70 meters south of the crossing and watches an eastbound train traveling at 60 meters per second. Do you need a copy? Okay.
Yeah.
Amber? Straw's got one. Amber, do you need one?
No, I haven't.
Oh, you got one, good.
Yeah.
You want one? I wanted 22. They're just additional practice problems. All right. Well, let's make a sketch of this. Observer, stand still, 7 meters south of a crossing. Let's just put a person here. There we go. 70 meters south of some crossing. And at that crossing, watches an eastbound train traveling at 60 meters per second. All right, there goes the train. Eastbound, right? It's going east. And that length's increasing, isn't it? All right. Am I okay if I call that A? You're right. This side's B, and DBDT I already can call 60, what do you units? Mpress. Meters per second. At how many meters per second is the train moving away from the observer 4 seconds after it passes here? So we're gonna go 1,000, 2,000, 3,000, 4,000, 4 seconds. And then we gotta talk about how fast is the train moving away from this person. And we get another right triangle, right? Cool. So that's 70, but if it's 4 seconds later, that's every second. Isn't this side pretty long?
Yeah, 240.
60 meters after 1 second, another 60 meters, another 60 meters, and another 60 meters. I mean, it's not drawing a scale, but it gives us an idea. This is pretty long compared to that 70. All right, so how long is B now?
240.
Is that okay with that? Yeah, cool. Yeah. 4 times that's 60. What were some common right triangle lengths? 3, 4, 5. What were some others? 5, 12, 13, 8, 15, 17. When I stole that problem from an old AP exam. Anybody know this triangle? 7, 24, and what?
25.
7, 24, 25. So you can tell the examiner, oh, 70, 240. If I'm lazy, I don't want to do Pythagorean theorem. How long would this side be?
250.
250. But if you didn't know these common right triangle lengths, that's okay. Do Pythagorean theorem, right? If I'm going to put it down right now, C is 250. I've got this rate. The question says, at how many meters per second is the train? Now, here's the train. All right. Choo-choo. There's the train. How fast is that train